Hi guys and welcome back. Now we're gonna have a couple of examples, okay, about about the type of indeterminate forms we did before. And our first example is gonna be we'll be finding the limits when x tends to the infinity of square root of x to the power of 2 minus 2 minus the square root of x to the power of 2 plus x, okay, and then close the bracket. Okay, at first look, if you plug the infinity here inside, the whole thing is going to give you infinity minus infinity, because this will go to the infinity and take minus 2 with it. This go to the infinity and then to infinity. Infinity plus infinity equals infinity, so we're going to have infinity minus infinity. This is actually type D we did before, but here there's a problem. We can factor with the greatest exponent. Right? There's no way to do that. Okay, even if we do that, we'll still have the infinity. So what we're going to do is that we're going to multiply this term here, I mean this expression here, by its conjugate. Okay, and the conjugate, remember the conjugate when you have A plus B, okay, and its conjugate will be A minus B. All right. And what we're going to do here is that we're going to multiply by its conjugate and divide by the same thing. Okay, so that's going to give us the limits when x tends to the infinity of the square root of x to the power 2 minus 2 minus square root of x to the power 2 minus plus x, and the conjugate now is the square root of x to the 2 minus 2 plus, okay, plus the square root of x to the 2 plus 2, and then divide by that conjugate, by this one. So that would be the square root of x to the power 2 minus 2 plus square root of x to the 2 plus x. Okay, why we're doing that? Because we are trying to change it into maybe some like this form or that other form, plus minus. Okay, because these forms are L'Hopital's friendly, and it is easy to use this for by taking derivative, but we can do that here. And here it's really easy. I mean, if you go ahead, just cancel this both thing here, we still have the. So I'm just kind of a trick, using like when you work on completing the square, you can add a term and then subtract it. So I just multiply a term and divide it again, so it remain come back to the same thing. So what I'm going to do now is just go ahead, multiply everything, right? So to do that, let me just make some rooms there to wipe this out. Okay. All right. So now we're going to multiply everything. So it's going to give us the limits x tends to the infinity. When you take square root of x to the power 2 minus 2 to the power 2 minus 2 times this one here, times the same thing, it gives you x to the power 2 minus 2. We take this term here, multiply by the other one, okay, it's going to give us a term, but I'm not going to write it because it's take long. But what I'm going to say is that this term times that one, it is having a plus, and this term is the same thing. This term times that one is the same thing, okay, but having a minus. So these both things, this here and that here, will cancel out, and the remaining term will be minus. So we have in here, we have it a square to the power to the b, x to the power 2 plus x, okay, and the whole thing divided by the square root of x to the power 2 minus 2 plus the square root of x to the power 2 plus x. So x, oh no, there is a mistake here. Here is minus 2. It's minus 2 because we have in here minus, and we're gonna have x to the power 2 plus x, and with the minus give a minus and minus. Okay, it is minus. Okay, so this one here is minus. Okay, okay, so still if we apply here, I first need to cancel out a couple of stuff here. This term here with that one will cancel out. Okay, and if I apply the limits in it, I'm gonna have infinity over infinity. Still have the same problem, so I can continue. Okay, I can take the derivative here. It's gonna take I can even take derivative, but there is also a simple way to do that, like we did before. Okay, so what we're gonna do here is that we're gonna remove the common factor, okay, with the greatest exponent at the numerator and the denominator. So the numerator can be looking like this, and the numerator I can write it like this. We got hold on. So we have in here limits here minus 2 minus x, okay, divided by, x goes to the infinity, divided by, let me just write like this. It can be like an x to the power 2 times, okay, 1 minus 2 over x to the power 2, okay, plus square root x to the power 2 times 1 plus 1 over x. Okay, and this is it, like this. As you can see, we can start to apply the limit on it. But if we do that here, we're gonna have this gonna go to 0, this gonna go to 0, and the x will come here. But we need to do the same thing at the numerator. So we're gonna say it is limits x tends to the infinity of, first write the denominator, and this is a common factor, means that this one is gonna go out because it's having a square, it become an x, and here the same thing, and be x, and this is a common factor for both. So I'm gonna say it is x square root r of I can even put the square bracket. Hold on, it's a little bit complicated to write like this. Okay, I got an x square bracket, and then brackets, then I have the square root of 1 minus 2 over x to the power of 2. Okay, this is here is gone. It was here, and because it was there, because it has a square, it can go out. Okay, so and I took it like a common factor for both. So this is 1. Okay, then I close it here and then open that 1 plus square root of 1 plus 1 over x. Okay, so x is here as a common factor for both. If I plug x back in there, it's going to be x to the power 2 here, and then minus 2, and x to the power of 2 here, plus x. Okay, this is the same thing. So I'll just go ahead, and in the numerator I have x times minus 2 over x, okay, minus 1. All right, now the x can cancel out, and this one here, when x tends to 0, this goes, with x tends to the infinity, pardon, this goes to 0, this goes to 0, this goes to 0. So we still have the limit x tends to the infinity of minus 1, and no, I don't need a limit anymore because we don't have any x in it anymore, so I don't need a limit. So go back, So this will be equal to, I have a numerator minus 1 over, and here it goes to 0, 1 plus 1. This is equal to minus 1/2. Okay, and that's the limit, that's the result of our limit, starting from an indeterminate form to get to the result here. So we can conclude by saying that the limits, or maybe further say that therefore the limit when x goes to the infinity of the square root of x to the power 2 minus 2 minus the square root of x to the power 2 plus x, close the bracket, equals to minus 1/2. Okay, and that's our result. All right. Okay, thank you for watching again, guys. We're going to continue doing a couple of exercises or examples in the next video. Okay, thank you for watching again. Until next time, bye bye.